All right, here we go. No, I'll check it after. I'll check it after I do the instruction. I'll do it after, okay? All right, first thing, before we start graphing anything, you need it in y equals form. All right, y by itself. So that's what I need your help with. How do I move that 3x over? Subtract it. All right, so I'm going to have negative 5y less than negative 3x plus 15. I always like the x to come first, and I'll show you why after we're done here. All right, y is still not by itself. Divide by, time out, everyone. Divide by a negative. Yes, I know, a 5. I got that. Negative. There we go. When you divide by a negative with the inequality, whoop, sign gets flipped. So it's going to be y greater than, all right, now you're going to divide each of them by negative 5. So what happens here? Negative 3 over that negative 5. 3/5 x positive. And then 15 divided by negative 5. Minus 3. Here we go. Let's graph it now. What are we going to the calculator for? All right, I'm hoping we can just use the y-intercept and slope to graph a few points instead of trying to plug it into y equals and going through that business. What's the y-intercept? Negative 3, that's the first point I graph. Negative 3 on the y-axis. From here, can you get me a point? At least one more point, because you need 2 points to graph a line. 3 would be clutch. Where do I go from here? What's my slope? 3 over 5. So you direct me where to go from that negative 3. Up 3. It's rise over run. Up 3. 1, 2, 3. What do you mean by over? To the right. 1, 2, 3, 4, 5. And then if I don't know about the way you set up your axes, but if I go up 1, 2, 3 over 5, I'm going to run out of room. But how can I go backwards and graph another one? Explain how I go backwards. 1, 2, 3, left 5. 1, 2, 3, 4, 5. Okay. Woo! Hold on. Before we grab our straight edge and graph in our line. Anybody remember what type of line I'm going to do here from the old algebra days? Dashed line. What makes it dashed versus solid? The or equals would make a solid line. Since there's no or equals, this will be a dashed line, yes. All right, so you can line up your straight edge right now. A dashed line. That scared me. All right, that's the first part, getting the line done. Second part, shading. I'm either going to go above or below here. How do I figure out? I test a point, preferably a simple point that's not on the line, which would be what for us here? Simple point. 0, 0, or 1, 1, sure. I'm going to go 0, 0, though. So I'm going to take, here you go, let's get back to business. I'm going to take the original equation, the original one, because you may have transformed it wrong. I'm going to go to the original equation and plug in 0, 0 for x and y. So I'm going to say 3 times 0 minus 5 times 0 less than 15. What do you get on the left side? 0. Is 0 less than 15? Yes, so that means 0, 0 is part of the solution, which means where should your shading go? Towards 0, 0, yes. All right. And that's why you have your colored pencils to do your shading. Meaning any point in the shaded region, any point you pick in the shaded region is an answer to that inequality, any point. A point on the line, no, because it's dashed. All right, but any point in this shaded region will be a solution to that inequality for x and y. How we doing, all right? Before we go 2 at a time now. Anything? Hannah, hello. If it was solid, any point on the line would be a solution, yes. Yep. Anything else here? Okay, let's do 2 at a time now. So go ahead, set up your XY axes if you haven't done so already. I learned this little trick years ago from one of my students, so you can see where they intersect, because sometimes it's a little tough. I saw him put a little circle around it to tell me that's the org. That's up to you, though. There's just to say, because eventually we're going to be graphing vertical and horizontal lines, and you want to know the difference between the x-axis and that line that you're going to graph. But that's up to you. I just thought that was kind of neat. All right, here we go. Let's start with 2x minus 5y is less than or equal to 10. Help me transform it. Very similar to the previous one. We're not dividing anything yet. Come on. What are we doing first? Subtract 2x over. So you get negative 5y less than or equal to negative 2x plus 10. Then we're going to divide by a what? Okay, what's going to happen here? Flip the sign, yep. So it'll be y is greater than or equal to, help me out, negative over a negative, 2/5 x minus 2. Stop me if any of the transforming part's probably the hardest. All right, honestly, you guys could go different paths than I'm going to go. All right, I like to solve for both of them, then graph them, then shade them. Okay, if you want to graph it and shade it, then go to the next one. That's your call. All right, but me personally, I think it's easier just to transform everything, graph everything, then shade everything at the end. Okay, so that's what I'm going to do with you guys. So next thing I need now is help me transform 3x minus 2y is greater than 6. First step. Do I still... They weren't working last time. I know you'd be devastated. Oh, lucky us. 8. Oh, calm down, boss. One step at a time. Subtract 3x. So I get negative 2y greater than negative 3x plus 6. What are we doing next here? Next, here you go, 7. What's up next? And what happens now if I divide by a negative? Yep, so less than. Here we go. Everyone help me out. When I divide that by a negative 2, that becomes positive 3/2 x. 6 divided by negative 2. Okay. Any issues transforming? Let's graph now. I'm going to graph each line individually. So let's start with this bad boy. Where on the y-axis do I start? Negative 2. Where do you want me to go from that point? Up 2 over 5. Up 2. 1, 2, 3, 4, 5. If you want to get another point on there, you can go down 2 to the left. 1, 2, 3, 4, 5. Solid dash. What do we got? Solid. I hate that. It's so annoying. Actually, you know what? I'm going to go straight black here. If you want to shade from there, go ahead. I don't like graphing a line in a shaded area, so I'm going to graph both lines first. Matt, go. I just don't understand how you know what points are. Okay, this is just reviewing algebra now. Ready? You have a slope and you have a y-intercept. This is called the y-intercept. That's where the graph crosses the y-axis. So at -2. The other part is called the part with the x is called the slope. And that's rise over run. So up 2 over to the right 5. Up 2 over to the right 5. Good? Two pieces to graph a line, the y-intercept and the slope. You always start on the y-axis where the y-intercept is. Good? All right. Help me graph the next one. Okay, Matt, here you go. I'll throw it to you. What's my y-intercept? So where should I start on the y-axis? -3. So I'm going to start right here now. And where do you want me to go from here using your slope? Up 3. 1, 2, 3 over 2. Up 1, 2, 3 over 2. Anybody want to tell me about the line for this one? That line right there should be? Dashed. Thanks, Hannah. Everyone, yes, it's dashed. Stop me here because I know some of you guys can fly by this. Some of you guys are struggling. There it is. Before we go to shading, how many lines do you have on one graph right now? 2. Anybody know why I asked that? At least one you got to label to let me know which one's which. At least one you got to label. And you can label it with the transformed one or the original one. Doesn't matter. I always label both. I go hardcore. All right, ready to shade. Let's start with the solid line. What point can I use again? 0, 0. Plug in 0 for x and y into the first equation. What do you get on the left side? 0. Is 0 less than or equal to 10? Yes, so on the solid line, where should I be shading with my colored pencil? Above, towards 0, 0. Go ahead. All right. All good? Shading? Go to the next one. Plug in 0, 0 again. Next equation. 3x minus 2y is greater than 6. When you plug in 0, 0, what do you get on the left side? 0. Is 0 greater than 6? No. So on this dashed line, you're going to shade away from 0, 0 because it's not a solution with another colored pencil. So on the dashed line, I'm shading away from 0, 0. And this is why I have you use the colored pencils. Anybody know where my solution will be? Anywhere where the shaded regions overlapped, and I need you to put a nice, solid, even in a different color if you wanted, S. That says any point in this, pick any point in this region right here, it'll be a solution to both of them. All right, pick any point in this region here, it's a solution to both of them. Well, that's beautiful when you use colors, huh? It's beautiful. You're welcome for getting the colored pencils. You're welcome. What? Goof troop.
No, just when it says y is less than, are there times when it doesn't go down? Because I thought that was.
Probably not, no, but I don't want to introduce that now. But yes, you're correct.
Sorry,
okay.
Yep. I was like, am I going crazy?
Yep. Anything else? How's everyone doing today?
All right.
Excited for break? Good to hear. All right. What?
Trying to hide it now. He's trying to hide it.
I'm not even going there. All right, next one. Go ahead. Graph your lines. I'm sorry, not graph. Graph your x and y axes. I didn't mean graph the lines. Graph your x and y axes. Again, I'm going to put the little 0 there at the origin. You'll see why definitely on this one. All right, are we ready here? Let's go here because this one might be a little confusing even though it looks pretty easy. There's not much there. There's nothing to transform. X less than or equal to 2. Anybody remember what type of line x equals 2 is? It's a vertical line going through the x-axis at 2. That's what we're going to graph. Is it going to be solid or is it going to be dashed? Solid. All right, so here we go. Grab your straight edge. A vertical line going through 2. X equals 2. Vertical line going through 2. And now maybe you'll see why I thought putting that little circle there is helpful. You can tell the origin from your line. There it is. I'm going to shade at the end. Y equals -1 would be not a vertical now, but horizontal, dashed or solid. Solid going through y equals -1. Oops, come on, you're better than that. Before I shade, how many lines do I have up there? 2. Label at least one of them for me. All right, make sure you don't label the x or y axes. X is less than or equal to 2, and this is y is greater than or equal to -1. All right, ready to do a little shading with me. X less than or equal to 2. Okay, you can still plug in 0, 0. Ready? Plug in 0. Is 0 less than or equal to 2? Oh, boy.
Oh, my God. Oh, my God.
Is 0 less than or equal to 2? Yes. So where should I be shading on this line? Towards 0, 0, so to the left. Yes. Ooh, you guys are making me nervous. So going this way. Going this way. Oh, I am even nervous now to ask this next one. If we can't get that one. Is 0 greater than or equal to -1? So where should I shade, above or below? Where should I shade, above or below? Above, yes, towards 0, 0 because it's a solution. And do we see where our solutions would be? Any issues? Yes, another one you asked. You got it. You need more. Set up your x and y axes for number 4. We're almost done here. All right, so let's think of, I don't think I need to say too much here. X is between -2 and 5. X, not Y, X. So what type of lines are we working with here if it's X? Vertical lines. One's going to be where? At -2, and it's going to be what type of line? Solid. And one's going to be at 5, and it's going to be dashed. Go ahead, and then we'll talk shading, even though I think some of you know where the shading's going to go. Put my little oval there. So -2, solid line. 5, dashed line. Label at least one. Well, actually, we don't need to label anything here because this is just one entire graph. It's not separate. Where's the shading? What do you think?
We're thinking that I want to say in between.
Well, where's the X?
Right in the middle.
It's in between. Even if you tested 0, 0, throw 0 in for X. Is 0 in between -2 and 5? Yeah. So it should be part of your solution. All right, so we're going to shade in between. Or you can draw horizontal lines too. That's always an option. Yeah, just throw a Y in there. Why not? Yeah. Just had one job.
Sorry, you got another one.
Anything, guys, here? Before we just, I know you're probably cringing. Oh, he's going to graph 4 of them. Yeah, I am. Are you sitting next to somebody else that you can share? Hi, Emma. All right, hey, quiet up, quiet. Here you go, Emma. For something like that, you wouldn't have to use 2, no. Yes, like going this way. You could use a color and going that way. Use a different one, and they intersect there, but it's not needed. Okay, so you're going to have to share colors here because, yes, we're going 4-bagger here. All right. Let's start. Okay, stop here because I want to make sure we're all good. Let's graph the 2 easy ones, the vertical and the horizontal line. Which one's the vertical line up here? Okay, so let's graph that, solid or dashed. Okay, everything's going to be solid, right? So at X equals -2 is going to be a solid line. And where's my horizontal line? Y equals 4, right? Another solid line at 4. Horizontal. 1, 2, 3, 4. All right, just remind myself, this was the X is greater than or equal to -2. This was the Y is less than or equal to 4. All right, I'll do all the shading at the end. All right, help. I'll let you guys just get another 30 seconds here to graph your lines. Can I get a little help transforming 3x plus y less than or equal to 6? Little help from 3?
Subtract 3x.
Okay, what's it going to look like, Jack? Y is?
Less than or equal to 3x plus 6. Or -3.
-3x plus 6. Matt, you may want to focus here because I'm throwing everyone for a loop now. What's the y-intercept? 1, 2, 3, 4, 5, 6. All our slopes have been positive so far today. How's this change things from where I go now if it's a -3? I could go one of 2 ways. I could go down 3. Ready? Watch. I could go down 1, 2, 3 over to the right. 1, or I could go up 3 and left 1. Okay? So 1, 2, 3 over 1. Graph that solid line in. You guys doing all right here, keeping track of all your lines? And I never had one to begin with. And then one more. Ooh, a little different here. Help me transform this one. Let's do it. 2, little help. Okay, so I have negative y less than or equal to negative 2x minus 1. Oh, he's going to keep going. Sure, Mark, go ahead. I wasn't prepared there, but go ahead. Divide both sides by a negative. So what are we doing with the sign? Flipping. So y greater than or equal to 2x plus 1. Let's go, Matt. What's my y-intercept? 1. And where am I going from here? Up to, oh, we got a little point of intersection, everybody, huh? I didn't need a backup. Up 2 over 1, yep. Up 2 over 1, just making sure I got it. Up 2 over 1. And then we'll graph that line in. All right, looks like it's shading time. Share colored pencils around you. Okay, we all ready? Let's go bottom up here. Let's go bottom up. Y less than 4, less than or equal to 4. Is 0 less than or equal to 4? Yes, so at this line right here, above or below the line? Ready? Is 0. It is, right? So I should shade towards 0, 0. We good? Shade below. Okay. New color. Help out, help out. Is 0 greater than or equal to negative 2?
Yes.
Okay, all right, stop. So where should I shade to the vertical line? To the right or to the left? Right or to the left? To the right, towards 0, 0. Whew. All right, here we go. Good thing for the colors. Swap here if we need to. Swap. Ready? 2x minus y less than or equal to negative 1. Be careful here. Plug in 0, 0. What do we end up with on the left side? Is, okay, I'm going to say this slow. Is 0 less than or equal to negative 1? No. So I should be shading away, which would be what for us? Above or below? Above this line here. One more. One more, everybody. Plug in 0, 0. What do we get on the left again? 0. Is 0 less than or equal to 6? Is 0 less than or equal to 6? Yes. So where should I go? Below or above this line? Below.
Oh my. Broke it. That even makes sense of that. It's like right. No, it's like I see it. It's like right there. It's like a triangle.
It's a triangle.
Yeah, I see it. I see it. Can't see squat.
You all right back there? Okay. Do you see your point of, do you see where all four intersect? No?
No, not really. Yeah.
Well, here you go. I can tell, hey, stop out. All right. I can tell you it's nowhere over here because I don't see any red. All right. I can tell you it's not anywhere over here because I don't see any orange. If you see it, it's right where that triangle was formed. Everyone see I got orange, red, blue, green all intersecting there. Last thing before we pack it up here. Last thing. Tomorrow, because you're going to have another one of these that's going to look like this tomorrow when you're working in your group. Another suggestion I might have for you is when you start shading, only shade where they're going to intersect. Like there was no reason for me to do all of these orange ones down here. Okay? You see what I'm saying? Only shade where you know things are going to intersect. Okay? Might be another decent idea. All right, I still need to see a couple of assignments from a couple of you. If you know you're not going to be here tomorrow, you know what the assignment is. Okay, you know what the assignment is. Please put the colored pencils and or sharpeners back in the boxes for me.